And hopefully the last couple of problems you remember doing them, and we did check the answer. I did it differently than they did, a little bit of steps, just substitutions of different equations. All right, this one was a very interesting problem. I'd never seen a problem like this one before in any of the AP problems or even in the other college material. This book, it's a good problem. I like it better now than I did last week when I was like, what the heck's going on? Well, the thing is, you don't see what the motion, you don't see the animation, and I wish this book would have had an animation for this picture. I'm going to describe it first. This is what I see. There is a point called P, and it's on the circle. And you're going to see where they describe P is starting up here. And P is moving that way. I knew she was going to get here. Evelyn, can you hear me?
Yes, sir.
All right, make sure you put it in chat because I might forget that you came in. So point P is moving down the circle here, and then there's point Q that is moving to the left on the x-axis. And the point Q is also connected to this tangent line. So what really happened is point P was here, and it tells us that it starts at the top. As point P moves, the line is moving, okay? And there is a line, well, except for being horizontal. Horizontal, there's a point Q somewhere that's not on the line. But if you notice, once it moves a little bit, there's always a point Q that is, well, that's too far down. Point Q would be touching this horizontal line that goes through the center of the circle. So it wasn't there. It's there. And obviously, as the line raises up, point Q is over here now, you see. And there is a point of time where point Q is not even on that line. So that line has to get almost horizontal, okay? So other than this horizontal, point Q is moving this way, point P is moving this way. So let's talk about what's happening here. It took me a while just to get that idea down. Particle P rotates clockwise at a constant rate. Okay, so we know it's rotating a constant rate. When you hear about rotating, that's the change of the angle. That there's an angle that it's rotating. Like I rotate 5 degrees, I rotate 10 degrees, whatever. So it's a constant rate. And it says that means it's as it goes around that circle, it's not speeding up or slowing down. It's just going around at a constant rate. Along a circle of radius 10 meters, centered at the origin. So that circle always has a radius of 10. So when that point P started up there, there was a radius 10. That's the radius of the circle. And now this dot's moving at a steady, steady rate. The particle's initial position was exactly at the top of the circle, like I said, 0, 10. And it said, that's on the x-axis, and its final destination was 10, 0. Well, 10, 0 meant it's still on the circle. That was its final destination. So we have to think about what's happening here. That means the arc of that circle is the same as the degrees or radians that it moved in there. So it's a quarter circle. That means it traveled, we can actually probably give it a variable. We'll see if I gave it a variable in my notes here. No, I don't think I did. Well, we're going to give it a, well, I guess I don't really need to know about the arc changing. we know that the x value of the circle is 10 at some point. And since, let's do what is changing. Theta is changing. So theta is changing. We know that. We know that theta changed from, that would be a 90-degree angle when it was like that. And it went down here, so that would be a total 90 degrees, which is in radians, pi over 2. It did pi over 2 radians. And he said, how long did it take? 30 seconds to travel from start to finish? In 30 seconds. Now you can run this problem in seconds, and I did that at home. And I said, oh, my answer didn't match because he didn't do it in seconds. He did it in minutes. Radians per minute was what he was looking at. D theta dt is some radians per minute. That wasn't a law. You didn't have to do minutes just because it's trig. You could have kept it in radians per second. So if he said that it was pi over 2 radians in 30 seconds, if I change the 30 seconds to a minute, that's the same as doubling it. Yes or no? 30 seconds to a minute would be doubling it. So this proportion, pi over 2 radians per 30 seconds, can become double the top number. Somebody, double pi over 2.
Pi, sir.
Pi radians per minute. But all rates of change, you have to ask yourself, because I always forget to ask myself and I make mistakes. Is this change of radians, is it going to be positive or negative as the angle starts up and the angle goes here and then it goes here? The angles are getting smaller. Do you see the angle getting smaller? So we would have to say d theta dt is a negative pi radians per minute. Now you can do pi over 2 per 30 seconds, but I guess it gets kind of ugly. The work gets kind of ugly. I did it, and the answer does work out. It just takes more steps, and it doesn't look pretty. Okay. Yes, sir.
What does it say on the blue part under pi?
I wrote radians per minute.
No, but okay, so it shows 30 seconds going to, is that supposed to be 1 minute?
Yes.
Oh.
You wanted, I'm using ESP. The truth is I did it once already in seconds. I did pi over 2, negative pi over 2 radians per 30 seconds. I used that in my mathematics, and the answer got kind of convoluted. It still works, it just takes longer. Then I looked at his answer and I said, oh, he cleaned it up by using in minutes instead. I'm just kind of like saying, I cheated. I'm giving you the head start that he didn't use seconds, he used minutes, which is cleaner than 30 seconds. It just is cleaner. There's no magic. You wouldn't have been wrong if you'd have kept it, but you might have made a mistake, how ugly it is. Okay, I need another formula. So I'm going to erase some of the stuff that I've written here on top because you can't see it all. What else does he say? I did the... All right. If it takes 30 seconds to travel from start to finish, how fast is point Q moving along the x-axis? So he wants to know if this is an x value out here, however far he is, then how fast he's going must be a dx dt, because that's changing. He's asking for dx dt. And I'm thinking ahead. X is moving left. The Q point is moving left. So that means the X value is getting smaller as you get closer to the origin. 0, 0. Therefore, it's probably going to be a negative answer. So it always pays off to ask yourself about Will my answer be positive or negative? It's going to be a negative. So if my work comes out and I lose my negative, you're going to have to bail me out and tell me what I did wrong. Now, this is what happens. He wants to know from start to finish that this point P started at 0, technically the x, and now it's at 10. But notice where the picture is. It's not at 10 yet, is it? He's not at 10 yet. So this point was in motion. And then we took a picture of it in motion and said, at right here, stop. I want to know when that point got to the start to the point got to here, I want to know what that rate of change is. Because if point P gets to here, then point Q is here. That's start to finish. So I want to stop the time and ask myself if I have me draw the picture of what it looks like. It looks like I got this little right triangle. This tangent line is on that circle. Think about that. And then there's this distance here. This is where Q is right now. And obviously it's not to the circle yet. So let me ask you, if you saw this triangle and we knew this was 10, where did he say about the angle? He didn't say nothing else about the angle, so we just have angle. We have an angle, we have this 10, which is the radius, and we have this distance that's in the picture that we froze time. He said that was 20. 20 meters, 20 meters and 10 meters. That's a right triangle. I need to know a formula that connects this radius leg with this hypotenuse, which is changing. The radius is not changing, the hypotenuse is changing. So what formula relates this, and this together? It's either geometry or it's trig.
Pythagorean Theorem.
But Pythagorean Theorem doesn't use an angle. Well, it does if you use law of cosines, but we're not using law of cosines. So I probably would try to be simpler. You have to use the angle. And without getting complicated with law of cosines, let's just talk about what else is left. It's a right triangle. Try again.
Isn't it cosine? Because it's adjacent and hypotenuse.
Adjacent over hypotenuse. There's my angle right here. That's an adjacent. And then this is an hypotenuse. I love it. Cosine of that theta at any given time as that triangle is moving and that point's moving, causing the tangent line to be moving, is adjacent over hypotenuse. One of those is constant. Which one of those is always constant? Is the 10 always constant or is the 20 always constant? Does the radius ever change?
No.
No, the radius will always be perpendicular to that tangent line. So I'm going to write, instead of adjacent, I'm going to put the number 10. Why do calculus on something that is always the same? Because the derivative of 10 is 0. So why do it? Next thing, hypotenuse is an x value that occurs on this. It could be 0. When it gets to here, it'd be 0. When it gets out to here, it's 20. When it's in here, it becomes 10. So I'm going to call it an x. Once we have an equation that is related to everything given in the problem, now it's time to do the derivative of both sides. What's the derivative of cosine?
Negative sign.
It is. And since it's with respect to time, it's negative sine theta d theta dt equals to the derivative of the right. Now you want to make your life easier. Make this look like 10 times x to the negative 1 power. That way I don't have to do quotient rule. I can use the power rule. Derivative of the right is a negative 10. Oh, by the way, somebody mentioned before I went out in the hall to babysit the hall for our whole 40 kids on campus, is there is going to be something for you to do today. It's going to be at the end of the period, my watch is going to go off, and you are going to have to submit some evidence of notes that you should have been doing forever, okay, when I lecture. So it'll be 2 problems that I'm asking to see. They may not be just 2 problems from today. They could be 2 problems from today. They could be 2 problems from last week, or they could be 2 problems from 2 weeks ago. So my alarm will go off, and then you will have a chance to go open up the assignment in It's Learning, which accidentally opened up for you earlier today, but it wasn't supposed to. I forgot to exclude you guys from 2A. That's why somebody saw it. So you need to make sure you're taking good notes, as always. I'm sure you always are. You're college students. Anyway, back to the derivative. That's negative 10 x to the negative 2. Go inside and do the derivative of the x with respect to time, dx dt. There's a perfect differential equation. Now it's our job to solve for what we're looking for, and I recall writing at the top, we were looking for dx dt. So that is very good that dx dt is inside my equation. There it is. And so now the point P, it moves, it stops, and I have to look at that picture again that I drew. That's where it stopped. Okay? So everything is in there. I'm just going to redraw the triangle by itself, because everything else gets in the way. 10, 20, theta, I don't know. So I don't know what theta is yet. I'm going to have to figure out what it is. D theta dt, I calculated d theta dt. Do you remember? Up here I labeled it. There it is. I have that. X, I think I know what x is right now. X is 20. So that's good. I have everything, and then there's dx dt that I'm looking for. So you have 2 choices. You can solve this for dx dt right now, and it gets kind of crazy. That means I got to divide both sides by a negative 10x to the negative 2. And you need to realize this really means 10 over x squared, doesn't it, with a negative in there? That's what this means, a negative 10 over x squared. So if I look at it like this, dx dt, it'd be the same thing as multiplying both sides by an x squared, and then dividing both sides by a negative 10, multiplied by that negative sign over there of theta, which I don't know yet, and then I have a d theta dt, which, oh, I do know d theta dt. Why don't I just skip that one step and put what it is? D theta dt was a negative pi, wasn't it? So now I got to plug in, I need an x, and I need, oh, I know what x is. What was x? Somebody? It's in the triangle. 20. 20 squared is 400 times negative sign. I need theta. Somebody help me out with theta. I need theta, and there's that negative pi. There's that negative 10. Okay, help me out with theta. This triangle. Do you remember, who was it? Was it Andres telling me about the cosine?
Yes, sir.
So if you said cosine is adjacent over hypotenuse, that's the same thing as cosine of theta being a half. Well, what special triangle uses a half in its sides? Do you remember? Right triangle, 1, 2, square root of 3. What must this theta be?
30.
I think so. I think so. Cosine of 30 is, let's see, here's the angle. Cosine's adjacent over hypotenuse.
It would actually be 60.
Oh, yeah.
The angle facing the square root of 3 is always 60.
It is a 60. You're right. Let's put it in radians. What's theta then? Pi. I was even thinking of a 3 because it's pi over. Because if it's 60, there's 3 of them in them. So it's pi over 3, isn't it? So that's what I'm going to plug in. Yeah, it's easy to. Cosine is 1/2. That is a, because across, wait a minute, across the street from the 30, if this one's 30, that's a 1 always across the street. Yep. Okay, let me finish plugging in. dx dt is 400 divided by a negative 10. I may as well get rid of that. That's a negative 40 times, oh, that's going to be a pi over 3. So what's the sine of pi over 3? Back to the same triangle. 1, 2, square root of 3. What's the sine of this angle? Opposite.
3 over 2.
Square root of 3. Say it again.
Square root of 3 over 2.
Yeah, square root of 3 over 2. And so 40 divides by 2 easily, and I get a negative 20 pi square root of 3. And the question is, if I'm looking for dx dt, was I expecting it to be negative? I said that somewhere. Up there I wrote it. Where did I write it? Right here. I was expecting it to be negative. And I may have something miscalculated. It's the right idea, but it takes a lot of thought. Let's see what the author has, because if I made a mistake.
Wait, sir.
Yes.
What happened to the pi? Because it shows negative in the brackets.
Where are you looking at? On my screen here?
Yes. It shows on the pink, it shows positive pi, and then on the black and bluish is negative pi.
I had a negative. Oh yeah, there should be another negative. Hold on. Okay, you're right. What happened here? There was a negative. Oh, I moved this negative. Oh, I moved this negative.
Because if you move it in front of the 400, then it would be positive 40.
Yeah, so there's got to be another mistake, because you're right, that would have canceled it out. That was negative. Who wants the extra credit? Find it. Anything else? Is there a negative that disappeared somewhere else? I think I did this earlier. Oh, I got it. I see it. If you see it before me, before I say something.
Would it be because of the sign?
The 2.
What 2?
The where you use squared. It's supposed to be a negative square, not just a square. For the x, or do you cancel that out?
I'm not sure where you're at. Up here?
Well, even if a negative is...
Yeah, that
Because,
negative 10 still would have been there.
yeah, well, on the black and then on the blue, it just says negative 10 over x, and then you have the 2.
Oh yeah, but that 2 is just the x, not the negative, not the 10.
Okay.
But
Or because of the sign?
no, well, no, it's not because
Oh,
of
right.
There's one here, and one here. So there's
Well, then-
one here, and one down here. So that meant there is one still left in the problem.
Yeah. Oh, okay.
Yeah, it wasn't wrong. It just
So that
overlooked.
means the pi would then stay positive?
No, it's not positive. It was going to be positive because I didn't see this one a second ago when I was looking in. I saw it when I was looking up. Oh yeah, there's still a negative here. Remember the derivative cosine was negative sine. So there was a negative sine, there was a negative pi, then there was that negative 10. I believe. Let's check what he had. That doesn't help. Let me check. Negative 20 square root of 3 pi. And then interesting thing that he did. He didn't put any units here. And so he would lose points. But then if you read his write-up, he said at the moment in question, the point Q is moving towards the origin at the speed of 20 square root of 3 pi. Then he actually did a calculator answer, which you don't have to do. On the AP test, I would tell you don't do this. He doesn't put the negative here. He has a negative here, no units. But he puts units here with no negative. So why would he get full credit? Because he wrote, in terms of its motion, Q was moving towards the origin. That implies negative speed, because it's going left. That's why he gets full credit. He has his units. He has the correct direction. He could have put it up here and he could have put miles per minute up here if he wanted to. Okay, guys, this problem here, my buzzer went off for a second period, and I had a mistake somewhere. So you're going to have to try to I'm going to try to do it a little simpler than I was doing it with them, because I got kind of a lot of different formulas going on. Let me explain what the gist is. Airplane is flying over a radar tower, and the airplane is 12,000 feet high. Okay? As it flies over, at the point that he reaches this location, the radar tower notices the plane's coming. Okay? The plane never gets lower than 12,000 feet, and it continues to fly over. And so let's summarize what he has. A jet airliner is flying at a constant altitude of 12,000 feet above sea level. It approaches a Pacific island. The aircraft comes within the direct line of sight of the radar located on the island. And the radar indicates that the initial angle, when he sees the airplane, the initial angle between the sea level and its line of sight is 30 degrees. So I'm locking it in. It was 30 degrees. How fast in miles per hour is the aircraft approaching the island when it first detected by the radar instrument? If it is running towards, or no, we're not running towards, it's running up. What's running upwards? The angle is running upwards. Counterclockwise, the angle is going up, because think about it. If it noticed it over here, or notices it over here, the angle is changing. That's a d theta dt. And he says d theta dt is opening, so it's going to be a positive something. He says positive what? 2/3 degrees per second. 2/3 degrees per second. There's a whole bunch of problems there. In order to keep the aircraft within the direct line of sight. So what we want to do is imagine that plane flying over. As soon as it reaches here, as soon as it's here, we take a picture and we lock in everything. Okay? So I'm looking at this triangle. I do not know how far he is, but I do know that's a right angle, and I do know that's 12,000 feet. I do know at that moment this angle is 30 degrees. So theta was 30 degrees. D theta dt is 2/3 degrees per second. So look at all the problems I have already. I'm going to give you a preparation. I don't do degrees in calculus. I need radians. So in a minute, I'm going to have to convert everything into radians. Also, he wants the speed. Well, if the plane is x miles away, and we want to find dx dt, he wants it to be in miles per hour. Notice my height is in feet. This is what makes this problem hard. I don't want feet. I want miles. I don't want seconds. I don't want seconds. I want hours. I don't want degrees. I want radians to do the calculus on. So there's a whole bunch of conversions going on here. But I'm going to try to do it simpler than I did in 2A. This is my picture that I stop in time. Let's look at it generically before I do any work. Theta, x, and unfortunately this stays as 12,000 because it's constant. What trig function would connect the 12,000, the x, and the theta together? Anybody? I gave you a hint. It's trig.
Tangent.
Tangent. Absolutely. So I'm going to write my equation. At any given time, tangent of theta has to be equal to 12,000 feet over x feet. Now, if I want to make this equation very simple, what did I do during lunch to make it simpler? Don't I want to find dx dt? So let me solve for x.
Sir,
Yes.
for the problem, this was kind of like last time. We can just switch the x and the tangent.
Yeah, that's
Because,
what I was going to do.
yeah, and
Yeah.
then replace the tangent with cotangent.
Yeah, you read my mind. And I didn't do that this morning, and so I wish you were there. If I solve for x first, it makes it easier. And what Mackenzie is saying, you multiply by x, divide by tangent. And then, if you don't want to divide by tangent, call it cotangent. So x is really 12,000 feet cotangent of theta. So that really is what I have here. But remember, we still got some conversions to do, and I just don't remember if I can convert afterwards or not. I think I will. I'm going to try. Do the calculus on both sides with respect to time equals to the calculus of 12,000, whether it's feet or miles or whatever, is still 12,000 because it's a constant. And the derivative of cotangent, that's the hard part. What's the derivative of cotangent, since Mackenzie made us get it harder? Derivative of cotangent. I got to work backwards. I got to say the derivative of tangent is secant squared. Therefore, the derivative of cotangent is negative cosecant squared theta d theta dt. So everything is there. I just got to find out what the angle was, and I have to find out what d theta dt is, which I sort of have it up there. So, and also I need a conversion for mile. This is feet. I need to convert that into miles per hour. So let's plug in what I can get first of all, the angle. Going back to the tangent. Or can I not do the angle? Do I know anything at this point? Did I miss something in the writing of the angle? Yeah, it was 30 degrees. I know the angle. I know the angle. I forgot. Theta was 30 degrees, right? But in radians. Pi over 6, right? So dx dt is that negative. I'm going to put out front so I don't lose it like I did the last time. Negative 12,000. And if I need to know if I have this perfect triangle, 30-degree angle like I have before, which is 1, 2, square root of 3, what is the cosecant of this 30-degree angle? It's the reciprocal of sine. Sine is opposite over hypotenuse. That's 1/2. Cosecant must be 2 over 1. So it's 2 over 1 or 2 squared. That's times 4. Now I've got my d theta dt. He told me that d theta dt was equal to 2/3 degrees per second. Is that what he said? I don't want to scroll up there and look. Yes or no?
Yes.
Okay.
Yes, sir.
So I want to put that in here. 2/3 degrees per second. I need to get rid of the degrees because I already got rid of the degrees here when I did the 30 here. I used pi over 6 for radians, remember? So I got to get rid of degrees. So the fastest way to get rid of degrees is to say that pi radians is 180 degrees. That cancels out the degrees. Now I have to get rid of this 12,000 feet. How many feet are in a mile? Come on, you.
5,280, sir.
Oh.
How much?
5,280.
There's 5, so 1 mile. And the reason I'm putting it on top, because I need miles per hour over 5280. No, that's 1 mile though. But how many feet did you say? That's 50 feet, right? So what happens now? That feet on top cancels that feet, and we are in miles. See the miles is there? I still got to get rid of seconds and turn that into hours. So I want miles per hour. I want miles per hour. So how do I convert seconds? Good luck. How many seconds are in an hour? Okay, that's too hard. How many seconds in a minute? Did somebody say it already?
Isn't it 3,600?
It is 3,600. 3,600 seconds per 1 hour. So that cancels out my seconds. All right, let's see everything I have written here. I have still here a negative 12,000 times a 4 times a 2 pi times a 3,600, that's at the top, and the bottom is 3 times the 180 times the 5280 miles per hour. Should be dx dt if I didn't make another mistake like I did this morning. I don't know what happened this morning. I didn't plug it at the end. I was trying to make conversions as I went. I think I may have multiplied too much. Let's see. What cancels easy? 180. 180 goes into 360 twice. So that gives me a 20. 2 goes into, where am I 2? 3 goes into 12,000. And that goes into 4,000. Anything else? Let's see. How about 20? How many 20s go into 5280? That should be a good number. How many 20s go into 5280? Somebody. Is it 2?
264.
264?
I think.
Okay.
That's what I
Everybody
got.
with them?
I don't have a calculator.
He's
Well,
right. It's 264.
264? Okay, so that's gone. That's 264 now. It's getting easier. Oh, how many 2's go into 264? 142. Now it's a 142. Does 4's go into 142? No, I don't think so. Okay, let's see what we got. 400 times 4, 1600, pi.
Sir, isn't it 132, not 142?
Oh, I don't know. You're probably right. 132. Thank you. Does 4 go into that one? Oh, 4 does go into 132 then. Let me erase what I wrote. Thank you. Who just helped me right now?
Elena.
Elena, thank you. Send me a message later. 132. Does 4 go into 132? I think it does. Goes in there 4 times. 34?
33.
It is?
33.
Oh my gosh, that's twice. 33. All right. So what do I have left? I got 400 times the pi miles over, that's gone, that's gone, that's gone, 33? Oh, I don't know if that's the answer either.
It should be 4,000.
Oh, it's 4,000. Oh, it's 4,000, not 400. Thank you. That was Ms. Rodriguez, right? You're quiet. I don't hear you through the speaker. 4,000 pi over 33. Can I get a decimal for that? Oh, there's hours. Don't forget hours down here.
380.8.
0.8
Yes.
miles per hour. This is my dx dt. If this is right, then I'm going to buy me a lottery ticket tonight, because that's a lot of ugliness. That's what made it uglier than AP. I told you the college stuff is uglier than AP. The AP will never make you do all those conversions. Drum roll, please be close. Be close.
Sir, it's supposed to be oh yeah.
Negative, because where my meg is right here. I lost it right here.
Yeah.
Why is it supposed to be negative?
Because it's
The
there.
plane is going.
Oh, it's going. I don't know.
What direction?
Counterclockwise?
Nope, the plane is not going around in a circle.
Up?
It's going left.
Plane's not going up either. It's going left. That's right. Constant
I said-
altitude.
I said
That's why
left.
it's negative. And they rounded it. And then he wrote down here miles per hour. Wow, I am buying a lottery ticket. And if I win the big bucks, I'll share it with all of you. I will send you a picture of my ticket, because that was a very ugly, look at, this is all he gives you for the answer. Really? Thanks a lot. You're going to tell me how I got any of this? No, he doesn't tell you how you got any of those numbers. How many minutes will my... Oh, guys, we got 5 minutes to spare before my bell goes off. All right. Nice job, guys. And if I do win the big one, I promise you, I'll share it with this class. Okay, this is from the textbook. I just decided that was all the textbook had as far as examples. I like this problem because it's very related to AP. Let's see how much I get done before the bell rings. If not, I can do a couple more the next day. But my math lab, you should be good to go. A sliding ladder. Okay, this is what it's about. You put a ladder against the wall, and if you don't secure the bottom of that well, your ladder can slide out from under you. And people have hurt themselves, the ladder falling. Okay, it does happen. This is a 13-foot ladder, and it's leaning against the house, and the base starts to slide away. Now, if Mackenzie was sitting on top of this ladder, she would not be crying. She would say, yay, it's fun, because it's just falling down. But, hopefully she can pick up her legs and it doesn't hurt her. And it's sliding away. By the time the base is 13 feet from the house. So in other words, there's motion going on, right? He says, by the time the base is 13 feet, Remember, the ladder was only how far tall? The ladder is only 13 feet, right? So by the time this occurs, that's the picture. Okay? That's still a right angle. The ladder has already slid down. By the time this occurs, the base is moving at a rate of 5 feet per second. We know that the base, which, by the way, the bottom of this I can label as an x, right? Right now, x is 13 feet, but at that moment, dx dt is, he said, was 5 feet per second. Okay, so that is your scenario. He's got it broken into 3 problems. How fast is the top of the ladder falling down the wall? He's asking me for, if I label this as my y, he's asking what is dy dt. I bet you any money it's negative. You agree with me?
Yes, sir.
B says, at what rate is the area of the triangle formed by the ladder of the wall changing? He's asking for what is dA dt. C, at what rate is the angle theta between the ladder and the ground changing at that time? That's asking for d theta dt. Now, when I start with A, and here's my picture. And oh wait, why did I put 13? I don't know this height. I lied. This is just y. I don't know the height. The ladder's 13 feet. Always. I made a mistake. This is the height, or I called it y over here. I called y. Okay, what would relate this side with this hypotenuse? They're not giving me an angle, so he's probably not asking me for that. And we're looking for dx dt, or no, we're looking for dy.
Wait, sir, could you repeat the question?
Yeah, what formula would I be needing if I want to relate these 3 sides of the triangle?
The Pythagorean Theorem?
This is the case for Pythagorean Theorem. X squared plus y squared equals the r squared. I'll just call it r. Don't know what else to call it. I can call it h for hypotenuse. Doesn't matter. Now that I know my formula, go straight across into your calculus. 2x dx dt plus 2y dy dt must equal to 2r, well that looks familiar, dr dt. All the 2's cancel out. I'm left with x dx dt plus y dy dt equals to r dr dt. And my watch is going off now, but we'll finish this one up here. Plug in what I know at that time. At that time, x was what? Do I know? It was 12. I labeled it down here. X is 12. 12 dx dt is what I'm looking for. How fast is it moving away? Plus y. That I don't know. That I don't know. How would I get it? Pythagorean Theorem. Y squared plus 144 must be equal to 169. Y squared is 169 minus 144. How much is that? Real quick.
25, which is 5 squared.
25. Okay. Y must be 5. So I'm going to plug that in now. 5 and dy dt. How fast was the ladder falling? Wait, did I mess up? How fast the top? That is what I'm looking for. He gave me dx dt. What was dx dt? No one stopped me. This one I do know. It's in the problem. What did he say?
5.
5? Oh, come on.
Well, it says right there on right. It's
5. It does say it right there. I don't know why I didn't catch it. 5 plus 5 dy dt equals to r, which is always 13, And by the way, how fast is the length of the ladder changing? What is my dr dt? It's a constant. What's the derivative of a constant?
0.
0. This is actually all equal to 0. I'm looking for dy dt. So dy dt must be the negative 60 moving it to the other side divided by 5. dy dt, the answer for A, must be a negative 12 feet per, what was his unit? What was he using for units? Feet per second. That's what dx dt was. All right, there's A. B, just to set it up for you, A must be 1/2 times x times y. Do the calculus. Plug in what we know. C, how is the angle changing? Some sort of trig function, using maybe the hypotenuse and the x. You could use several trig. I would probably use that one. I'd probably use cosine. I would probably use cosine of theta equals to the x over 13. All right. Go ahead, guys. See if you can get ahead of me. I'm going to stop sharing this. Look into its learning.